Okay, day 3, here we go. Alright, here's our data. Oh, we don't have code open. Oh, we don't even have the right operating system up. Oh, this is costing us time! So much precious time! Alright. What is going on here? Okay. We're ready with day 3 already? Yes, alright, let's go. Here's my input. Okay, let's go read the thing. Diagnostics report, list of binary numbers. First parameter check is power consumption. You use the binary numbers to generate 2 new binary numbers, a gamma rate and epsilon rate. Each bit in the gamma rate is determined by finding the most common bit in the corresponding position of all numbers. For example, given the following, blah, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. Most common second bit is 0. Okay, yep. Gamma rate is 10110 or 22 in decimal. Epsilon rates calculated the same way. Rather than the most common bit, use the least common bit. So, yep. Okay. Multiply them together to get the stuff. All right. All right. So these are fine. We're going to do line to character array. Sounds reasonable. Right. Var. Var. Gamma is 0L. Var. What did they call that? Epsilon. Is that what it was? Gamma rate. Epsilon rate. Epsilon. 0L. For each, let's see, what we want is line in data. We want to, let's not do that. Let's do it like this. Index is 0, index is less than data 0, length. All right. Let's see. We want to count for each of these. We want to count zeros, ones, let's see if let's see, line sub index is equal to 0. Right? Yep, it's equal to 0, then double plus zeros, otherwise double plus ones. And let's see, so these are strings, because we're going to turn them into strings, right? So we're going to say most common goes into gamma, the least common goes into epsilon. Okay, so if zeros is greater than 1s, then we're going to say gamma, you get a 0, and epsilon, you get a 1. Otherwise, the opposite. And then we want to say long parse gamma. There is a way to set the base here, right? Number styles. Number styles. No, so nothing for binary? That's weird, right? We don't have to do this as strings. We could do it another way. We could do it like this, right? So we'll say here is gamma times epsilon. Okay, so if zeros are greater than ones, then we're going to put a 0 at the front of gamma, which means you just get epsilon times 2 plus 1. And we do this backwards like this. Gamma is gamma times 2 plus 1, and you're just times 2. That should work. We're probably running the wrong thing. Alright, we're running the wrong thing. Does that give us, that gives us 198. Okay, where's my real puzzle input? Okay. That's my answer for part 1. Okay, let's go. Part 2. Next, verify the life support rating, which can be determined by multiplying the oxygen generator rating by, both the oxygen generator and, okay. Valve diagnosis. Finding them is a tricky part. Both values are located in a similar process. Let's see. Before searching for either rating value, start with a full list of binary numbers from your diagnostic report. Consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you're searching. If you only have one number left, stop. This is the rating value. Otherwise, repeat the process considering the next bit. The bit criteria depends on which type of rating. So, oxygen, determine the most common value in the current bit position. Keep only numbers with that bit in that position. 0 and 1 are equally common. Keep the values with 1 in the position being considered. What? From the least common value in the current bit. Keep only numbers with that bit in that position. Okay. We're certainly going to do this again. So for oxygen generator, start with all 12 numbers. So there are more 1 bits than 0 bits, so keep only the 7 numbers with 1 in the first position. Then consider the second bit. There are more zeros than, okay, so in the third position. Okay, so we need, let's see, so these are going to be oxygen and CO2. So oxygen is data to array. CO2 is data to array. And now we're going to do 2 lists rather than 2 array, because we're going to want to pull things out of the list. Let's see, so we're still going to do this, the zeros and ones. Let's see. If you have only, alright, let's see. Determine the most common value. If they're equally common, keep values of the 1 in the position. So we check for zeros greater than 1s again, right? If zeros are greater than 1s, let's see. We'll do index 2. So we're going to start at the end of oxygen, like count -1, IDX2 greater than or equal to 0, double minus IDX2, right? For oxygens, when there's more zeros than ones, we're going to say if if shoot, we have to do this twice, don't we? So that's oxygen. If oxygen at index 2 is equal to 0, so oxygen is the most common value. So we want to get rid of this. We want to say oxygen remove at index 2. Wait a minute, data is a double array of characters, right? So oxygen is a list of character arrays? Right. There you go. And then this is going to be CO2. Oops, that's index. Sorry, that's index 2 still. This is now CO2. Oh, no, wait. This is still oxygen. My bad. I'm dumb. And we need to stop when we have only one left, right? So we also have to say if oxygen count is equal to 1, we break. I need to go back to the old data first. All right, oxygen count is 1, break. And there's only one left. The oxygen is blah, so we have to convert that into decimal. Why don't I know how to do this? It's fine, actually. All right, so we should say oxygen value is 0 for each var CH in oxygen sub 0. If CH is 1, right? We do this. We say oxygen value. You get double. Then if you're there, then oxygen value goes up. Let's return oxygen value just to make sure we're doing the right thing here. So our oxygen value is 23. All right, and CO2 is 10. All right, so what I really want to do is I really want to make this a function. All right, I want to make this a function, which is long get value. Let's see. There's a flag I'm going to need to pass here. I'm not sure what to call that yet. So here we've got data sub 0. Here we've got values is data to list. All right, so here we've got values. Values, 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 values. We're done. Values. This is result. Return result. We need to know, let's see. Terminal least common is there, keep the values with 0 in the position being considered. So we want the considered value. I want that to be a char. All right. Yeah, so this is going to be considered value, right? So then what we want is we want to return get value of 0. That should return 10 now, right? It's 30. Get value of 1. 2. Wow, that's wrong on both counts. Values. So if it's zeros, if zeros are more than ones, zeros are well, the least common value. That's What if we do that? Does that get us back to where we want? That still gets us 2. I don't understand 2. We should get 23 and 10. $30. Data 0.length. Values of the list of chars. Data is okay. Data 0.length. Sure. Primary, and we'll say secondary. How's that? So if primary is greater than secondary, I keep screwing it up. I don't know what I'm doing. I keep getting 2 and 30. 2 and 30. Should get 23 and 10. So, line is a char array. By the way, these could have stayed as strings. Don't know why I didn't leave them as strings. I'm sure they're still going to get 198 and 30. Okay. Primary. So if we want ones, right, then we count ones as primary. So if we want ones, then we want to say if you don't have the considered value. Okay, that's probably why. That's probably why. 22? What? 22? Where do you get 22? 23 and 22. So 20 zeros should have been 10. Oh. All right. Console right line line. All right, so we're looking at ones. We're looking at index line. All right, so we're looking at ones. Console right line. Primary. Primary. Secondary. Secondary. Removing values IDX2. Removing IDX2, values IDX2. Removing IDX2, value IDX2. Okay. So we can figure out what's going on here. Okay, so at the start we have all of these. All right, so primary is 7. 1, 2, 3, 4, 5, 6, 7. Yep, secondary is 5. 1, 2, 3, 4, 5. So that part's working. So remove index 11 because those are all zeros. And now we only have all of these. And so primary should be 1, 2, 3, 1, 2, 3, 4. Okay, that's good. So we remove all the ones, right? So ones win, so we remove the 0. Ones win, so we remove the 0. Ones win, so wait a minute. Primary is greater than or equal to secondary. All right, so that's 23. All right, so I don't get this now. Let's go back up here. All right, so this should be backwards. Primary 5, secondary 7. So we should be removing the 5 zeros because we're after. Wait a minute. So the primary is zeros. Secondary is ones. So we should be removing all the zeros. We do. So we just have ones. That's weird. How, like, that doesn't seem right. What am I missing about this? What have I done incorrectly? We want the least common value. We want the least common value. Okay. So this is the problem. Cool. Least common. So get value for false. So this is going to be 0. All right, and now this is going to be zeros. It's going to be ones. So we want to say if least common and ones are greater than zeros, or zeros are greater than ones. Okay. Then we just want to remove the ones here. I want to remove the zeros here. Well, I really messed this part up. Really. 20. So zeros are greater than ones, and we want to remove all the ones. Otherwise, we want to remove all the zeros. However, if we're looking for least common and ones are greater than or equal to zeros, although least common, 0 and 1 are equally common, keep the zeros. So I get 2 for that, which is what I expected. Why don't I get 23? Primary and secondary are equal. Let's be like that. Yeah. 23 and then 2 still. 23 and 2. All right, well, let's try it with the real data. I don't know where my real data went. Apparently got lost in time. Oh, and we need to multiply. Anyway. So we want to return get value true times get value false. But index out of range must be non-negative less than size of collection. Where were we? We're at line 101. Can't remove them all. What did I do wrong here? Text is wrong anyway. Zeros, ones. Doesn't say what to do in this case. Because I basically got to the end and I had nothing. I should never have had nothing. Clear. Clear. Run. Let's make sure that So we have zeros, so we're removing all the ones, right? That looks correct. By the way, there's 1,000 of these, so that should be 1,000. Okay, good. So we're removing 494, so there'll be 506 of them left. We don't remove anything that's incorrect. Yes? Okay, so now we have a bunch of zeros and a bunch of ones. I'm not going to count them all. I assume counting works correctly. So we had 506. That's 506. So zeros win. So we're removing the ones. Okay. That all look like ones to me. Let's see, what are some other things we can do? Because there's too many of these. Let's see. Let's var remove count 0. So rather than doing this, let's do double plus remove count. All right, and rather than doing this, let's do double plus remove count. Let's not write these either. Let's see. Console write line remove count is remove count. See what happens here. So we removed 494, removed 244, removed 125, we removed... Wait a minute. Why did we remove 63? Or why didn't we remove 63 here? We should be removing the losers. Why are we always removing the ones? The zeros are greater than the ones. Wait a minute, least common. This logic has to be wrong. Okay. So these are the zeros. Zeros greater than ones. Ones that must be greater than zeros. All right. So remove the losers, we remove the losers, we remove the losers, we remove the winners. There's something wrong with this logic. Did we get through false? Okay, let's go through false first. Yeah, so we go through false okay. Remove the losers, remove the losers, remove the losers, remove the losers, remove the losers. So this is true. So if you're least common and the ones are greater than the zeros, then we want to remove the ones. Did I screw this up because I needed to do that? Is that what happened? That's going to be dumb. Of course that's what I did. That's dumb. That's just dumb. Not the right answer. Let's go back to the old data. Let's do this. Let's go your your epsilon, I forget. No, your oxygen. All right, CO2 get value true. I forget which. Oxygen times CO2. Oxygen is most common, least common. Console right line. Oxygen is oxygen. CO2 is CO2. All right, this is the old data. 23 and 15. 23 and 15. 23 and 15. Are we back to, I should have left that as greater than or equal to? 23 and 10. All right, that was just dumb. Do we get an answer this time? We get another answer. It's different. Let's try and submit it. Okay. Wow, that was a huge number of mistakes. That took way longer than it should have. Okay, let's go see how we did on the leaderboard. We're doing okay there. And I'm sure we dropped a spot here. Yes, of course we did. Yeah, that's not too surprising. But wow, that was a really bad showing on my part. That was a lot harder than day 3 should have been. I don't know what to say other than whatever. Well, I guess I'll see you tomorrow, huh? Maybe tomorrow will be better.